Hi guys, in this tutorial video I'm going to teach you factors and multiples. You are also going to learn prime numbers from between 1 and 100. I'll teach you how to calculate prime factors of numbers, determining LCM and HCF of numbers. Subscribe to this channel if you have not done so. Turn on the notification bell so YouTube can show it to other learners. Let's continue. Factors. Now, what is a factor? If a whole number divides into another number without a remainder, that number is a factor. So we can simply say a factor is a number that will divide another number without a remainder. It is best explained this way. Now, when we have a number 40, so we can divide this 40 by 5, and the answer is going to be 8. The same way we can divide 40 by 8, and then we are going to get 5. So both 8 and 5 are factors of 40. It's very simple. Now, in a simple sense, it means that 8 and 5 can divide 40 without any remainder. Okay, so factors are always a number, or are always numbers that divides, go into another number, divides it without having a remainder. Okay, now I'm going to teach you how to find the factors of numbers. Now, let's say, for example, we have a number 40, and then we're asked to find the factors of the number 40. Now, how do you find the factors of 40? And the first thing you do is by writing 40 and then rule a line this way. Now, there's a technique you would always need to use, a very simple techniques. Now, we're going to look for two numbers by which, when we multiply these numbers together, we are going to be getting 40. It means that the product of these two numbers will give 40. Now, I would also say here that the two numbers definitely automatically become the factor 40. Now let's look at it. Do not forget, we're always going to start with 1. Why? Because 1 is a factor of every numbers. 1 will divide all numbers without a remainder. Now, so 1 multiplied with 40 equals 40. Okay, and then we have 2 times 20 would give 40, and then we have 4 times 10 would give 40, and then we have 5 multiplied by 8 would give 40. So Bula, these are numbers, or these are factors of 40. Now, always write these numbers in this order. Okay. Now, by placing this arrow, it means we're going to start from writing it. We're going to start by writing 1, 2, 4. Always put a comma to differentiate the numbers. 5, 8, 10, 20, and 40. Okay, so these are numbers, or these are factors of 40. So this is how to generate factors of a number. Do not forget also that you are meant to start in an ascending order. So it means you're going to start with smaller numbers into the larger numbers, okay, so that you don't have to make mistakes or skip digits. Okay, now let's do another one. Let's see. For example, let's say we are asked to find the factor of 36. Now, you always rule a line this way. Now, we're also going to look for two numbers that when we find their product, the answer gives 36. Let's go. Now, we have 1 times 36 as usual. 1 is a factor of every number. 2 multiplied by 18. 2 times 18 gives 36. 3 times 12 gives 36. 4 times 9 gives 36. And 6 times 6 gives 36. Now, why do I know these things? You have to familiarize yourself with the multiplication table. So by now, I'm sure you should be able to know the multiplication table of digits 1, 2, 3, up to probably 20. Okay. Now, it is good that you familiarize yourself with this so that factors can be very easy for you to solve. Okay, so you always know two numbers that gives you a particular number if you are being asked. So now, just like I did the other one, I'm going to write this one this way too. So I'm going to write the answers out. So it's always good to write the answers out. So you have 2, 1, 2, 3, 4, 6. Now, I'm not meant to write this 6 again, okay? Because I'm just supposed to write one of them. So I'm going to write 9, 12, 18, and 36. So these are factors of 36. It is very simple. Multiples. A multiple of a number is exactly divisible by that number. In a simple sense, we would say a multiple is a repeated addition. So when you repeatedly add a number to itself and to itself that way, it keeps giving you the multiple of that number. Now, what am I saying in a simple way is when you have, for example, when you have 4 plus 4 plus 4, it keeps giving you the multiple of what? 4. Okay, because 4 plus 4 gives 8. 8 plus 4 gives 12. 12 plus 4 gives 16. And then when you have another 4 this way, and you have another 4 this way, and you have another 4 this way. So when you keep adding it, it keeps giving you this gives you 20. You add 20 to this 4, it gives you 24. You add 24 to this 4, it gives you 28. Now, this simply means that multiple of 4. So the multiple of 4 is 4, 8, 12, 16, 20, 24, 28, that way. Now let's look at, let's find or determine the multiple of 5, for example. Now the multiple of 5, we're going to keep adding 5. So we're going to say 5 here, 5. And then when we add 5 to 5, it gives you what? It gives you 10. And then you add 10 to 5. It gives you 15. And then add 15 to 5. It gives you 20. Add 20 to 5. It gives you 25. If you add 25 to 5, it gives you 30. Gives you 30. 30 to 5 gives 35. And 35 to 5 gives 40. That way. Okay, so multiple is a repeated addition. It is very simple. So if you ask to find a multiple of any number, all you need to do is just keep repeating the number, and then you keep getting the multiple of that number. Prime numbers. Now, what are prime numbers? Prime numbers are numbers which have two different factors. Okay, this number or these numbers have only two factors, themselves and 1. Okay, now for example, you have number like 2, 3, 5, 7, 11 and 13. Okay, so these numbers have just two factors, means that they can be divided by themselves and 1 only. No other numbers can divide them. So in a nutshell, we can say these numbers have just two factors, 1 and themselves. Now number 1, for example, do not have two factors, so therefore 1 is not a prime number. 1 has just one factor, which is 1. So 1 is not a prime number. Now let's look at this. Let's look at this chart. Okay, this chart contains numbers from 1 to 100. Now the one in the light blue inks are prime numbers. Now there are just 25 prime numbers between 1 and 100. Now look at them. So you have 2, 3, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89 and 97. These numbers are prime numbers, and there are 25 of them between 1 and 100. Okay, now these numbers have just two factors, themselves and 1. So it means that 1 and these numbers themselves can divide themselves without a remainder. No other numbers can divide them. For example, when you have let's say 4. Now why is 4 not a prime number? Now 4 has factors like 1, 2 and 4. Okay, so now 4 has more than 2 factors. 4 has 3 factors. Now this makes 4 not a prime number. The same thing with 6, the same thing with 8, 9 and 10, and all other numbers in white ink. So the numbers in the light blue inks are prime numbers, and then there are 25 between 1 and 100. Prime factors. Now, what do we understand by prime factor of a number? Now, the prime factor of a number are the factors of the number that are prime numbers. It is possible to write every non-prime number as a product of prime factor. For example, when you have 15, 15 is 3 times what? 5. Now it means that 3 times 5 gives you 15. Now look at these two numbers. These are prime numbers. Okay, 3 is a prime number and 5 is a prime number. Now the product of these two numbers gives what? 15. So 15, so 3 times 5. This is a product of prime factor of 15. Now let's look at another one, 24. Now 24 is 2 multiplied by 2 multiplied by 2 and multiplied by what? 3. Now these numbers are prime numbers, and then they are factors of 24. Are you getting my point? Now, I am going to teach you how to solve prime factors, or how to determine prime factors of a number. Now, but before you do that, you must follow these points. Now, always start with the lowest prime number. 2. Find out if this will divide into the number. Okay? If it will not divide, try the next prime number. And I'm talking about numbers like 3, or 5, or 7, or 11, or 13, and so on and so forth. Okay? Now, the second thing you should always take note is, if a prime number will divide, check if it will divide again before moving on to the next prime numbers. Now, always be very careful. Let these 2 points guide you always. Okay, so now I want to show you how to calculate prime numbers. There are basically 2 ways to determine prime factors of a number. Now, you have the prime factorization method and the factor tree. Okay, let's take a work example to buttress these points. Now, we are going to find the prime factor of this number, let's say number 64. Okay, now the first thing you are supposed to do is you're meant to rule a line like this one, and then another one like this. Okay, and don't forget, you keep dividing by the lowest prime number, which is 2, and if 2 cannot divide, you try 3, and then like that. Make sure it's strictly prime numbers. Okay, now let's look at it now. Now, 2 we divide 64, and then you're going to have 32. Okay, try 2 again. Let's divide 32 by 2. 2 will divide 32. That will give us 16. Okay, so we're going to use 2 again. 2 in 16, that's 8. Okay, 2 in 8 will give 4. 2 in 4 will give 2. And 2 divided by 2 will give what? 1. Now, so the idea here is to reduce this 64, that is this number, to 1 by dividing by just prime number. So now 64, the prime factors of 64 are 2 times 2 times 2 times 2 times 2. Now let's see 1, 2, 3, 4, 5, 6. So there are 6 2s. 1, 2, 3, 4, 5, and let me write the times very well. Then you have another times, and then you have 2. So now this gives you 64. Okay, so these are prime factors of 64. Now, if you want to put this number in index form, then it's going to be 2 raised to the power of let's see, 1, 2, 3, 4, 5, 6. So it's going to be 6 into 2 raised power 6, and that is 64. So 2 raised power 6 is 64. Now, doing it this way, you put it into index form. Okay, now let's solve it again using the tree method. Okay, the factor tree. Now the factor tree goes this way. So you have 64 like this one, and then don't forget you rule the same line like this. Now we can as well find the prime factor of numbers by a method known as factor tree. This method involves the gradual splitting of numbers into 2 simple factors. Now look at what I want to do. So I'm going to look for 2 numbers by which when I multiply them together, I am going to have 64. These numbers may not necessarily be prime numbers, okay, but then we're going to coin out prime numbers from it. Okay, now look at it. Now you have, I'm going to start like this: 2 multiplied by 32. Okay, fine. And then you have one prime numbers like this. So you see, you have one prime number like this one, but this isn't a prime number. So I'm going to split this one like this. You can see I'm spreading 32 just like a branch of tree. Okay, so that is why it is called factor tree method. Okay, so I'm looking for a number that gives 32. So now let me say, don't forget I told you that you have to be conversant with your multiplication table. If you do that always, or if you do that, the multiplication table won't be your problem at all. So it'll be very easy for you to find numbers that gives you that. Okay, so I'm going to say, let me use a number like 4 multiplied by 8. 4 times 8 gives 32. So I have 32 this way. Now you can see both numbers are not prime numbers. So I will split them using my branch or my branches like this. Now for 4, I have just two numbers like this. Now 2 multiplied by 2 gives 4. Both numbers are prime numbers. So I'm going to circle them this way. I'm going to split this one like this one, like this again. So I have 4 multiplied by 2. I have 2 here. I'm going to circle 2 here. So I have 4 here again. I'm going to split it till I have all numbers become prime numbers. Okay, so I'm going to circle it this way. I'm also going to circle this one this way. Now, bullseye. So you have your prime numbers circled. How many of them? You have 1. Let's count 1. You have 2. You have 3. You have 4. You have 5 and 6. So that is 2 raised to power what? 6. That's putting it in index form. So this is simple. This is very simple. It is a simple way to solve prime factors. Now let's take other example. What if you have numbers that are very what if you have a very high digit number, such as a number like 5, sorry, when you have something like 15,288. Wow, this is going to be very tough. Now let's solve it. Let's simplify it. Now don't forget, you're going to rule your line this way. Always rule your line this way, and then something like this, very neat. Don't forget, this is prime factorization method. Now this is where you have to, this is where all your basic skills has to come up. For example, your multiplication skills, your divisibility skills. Okay, so now we have 8 here to end this number, so I'm sure 2 will divide it. Now 2 in 15, it gives me 7. Okay, remainder 1, I'll put the 1 here, so I have 12. 2 in 12, that is 6. 2 in 8 gives me 4, and then in the other 8 gives me 4. Very simple. I could still divide by 2. 2 in 7, I have 3, plus 2 times 3 is 6. So remember that 1, I'll put the 1 here. 2 in 16 gives 8. 2 in 44 gives 22. Let me put it that way. So I could still divide by 2. 2 in 3 is 1. I'll move my 1 this way. I'll carry my 1. 2 in 18, that is 9. 2 in 22 gives me 11. Voila. Now, so I have 1,911. Wow. If I use 2, 2 won't divide. 2 won't go very well. Okay, 2 won't divide it very well. Now let's see to be sure. Let's see. 2. 2 in 19. Okay, 2 in 1 is impossible. So now let's put this 9 there. It becomes 19. 2 in 19. That gives 2 in 19. Now let me use my calculator. Always let me use my calculator. Yes, so I have to be fast. 2 in 19. That's 9. Okay. Basically I'm going to carry my 1 here. Okay, so this gives me 11. 2 in 11, that's 5. And I have 1 here. So you can see 2 in 11. 2 cannot divide 11 properly. So 2 won't divide 1,911. So I just did it to show you that 2 cannot divide. So you look for another prime number which will divide this number without a remainder. And then you keep trying different prime numbers. I've shown you the charts of prime numbers. Okay, so keep dividing that number by each of the prime numbers till you get the one that will divide this number without a remainder. So 2 will not divide this. So I'm going to take that out. Okay, so I'm going to try 3. Now let's try 3. So 3 in 1, it won't divide 1. So I'm going to add this 9 to it, and then that's 19. 3 in 19. Okay, that will give me 3 times 6, that's 18. So I'm going to have my 6. 18, 19 minus 18, that's 1. So I'm going to have my 1 here now. 3 in 11, that is 3. I'm going to have remainder 2. So I'm going to have my 2 here now. 3 in 21, that gives us 7. So you can see 3 is a factor of 1,911. So I have 637. So I am going to try 3 again. Let's see, 3. The 3 will go. 3 in 6, that's 2. 3 in 3, that's 1. 3 won't divide 7, so 3 cannot go. So I'm going to use another prime number. I'm not going to use 5 because 5 isn't a factor of 7. So I'm going to use 7. Now let's try 7. 7 in 63. 7 in 63 is 9. 7 times 9, 63. And 7 times 7 into 7 is 1. So 7 is a factor of 637. And then let me try 7 again. Let's see if 7 will divide 91. So 7 in 9, that's 1. Remainder 2. So 7 in 21, that is 3. Beautiful. So I have 13. 13 is a prime number. If you check the chart, you see 13. 13 is a prime number. So I'm just going to divide 13 by itself, and I'm going to have 1. See, I have been able to divide this number 15,288 into 1 by using these prime numbers. So, and then I have it written out as 2 times 2 times 2 times 3 times 7 times 7 times 13. So this gives me 15,288. Now follow this step, you'll be able to solve any number. You'll be able to put any number. You'll be able to determine the prime factor of any number. It is very simple. Now, if I want to put this into index form, I can as well say, now look at it, I have 3 2's here. So I'm going to say 2 raised to power 3 multiplied by, and then how many 3 do I have here? So I have just 1 3. I'm going to say 3. I can as well put raised to power 1. I may not put it. It's the same thing. Times how many 7 do I have? I have 7 raised to power 2. 7 raised to power 2, and then 113. So I have 13 raised to power 1. Okay, now I've been able to put this number in index form. So I'm going to write this value as a comma, or I might not even put it at all. So I'm write as a comma. So that's 15,288. Now let's quickly use the prime the factor tree to determine this. Let's see. There's a factor tree to determine this. Now I have 15,000 to 8. So I'm going to look for two numbers. I'm going to look for two numbers that when I multiply together, I'm going to have 15,000. Now, basically, I'm going to draw my tree out this way, my branches this way. So I'm going to divide by 13. Let me see. So I have 13 multiplied by 1,176. Boom! This will give me 15,288. And then I have 13 as my prime, as a prime factor. So I'm going to circle. Don't forget, when you have one number as a prime number, all you need to do is circle it so that you know that, okay, you have one. So I'm going to split this one now. So I draw my branch. I'm going to divide it by 2. Let's see. So I'm going to have 2 multiplied by 588. I'm going to have it this way. Okay, now 2 is a prime number here. I'm going to circle it this way. So I am going to try look for a number. So I'll say 21 multiplied by 28. Okay, these two numbers would if you multiply these two numbers, you're going to have 588. Okay, now look at these two numbers do not have prime numbers, so I'm going to split them. I'm going to look for, okay, so now let me say 3 times 7 gives 21. Both 3 and 7 are prime numbers. I'm going to circle them. I would find two numbers for this. Okay, I have 7 times 4. Okay, so I have 7 as a prime number. I'm going to circle it. Now look at 4. I'm going to split 4 into 2. So I have 2 times 2. I'm going to circle 2 and 2. Now let's see if it's the same thing as the first one. So how many 2's do we have? We have 2 raised power 3. Okay, we're putting it in index form immediately. So we have 1, 2. So you have 2 in 3. And then you have 3. You have 1, 3. You have 1, 3. Multiplied by, what is the next number? I think 7. So you have 7 raised power 2. You have 2 7's. And then you have 113. So voila, it's the same thing. So this is correct. So 13 is power 1. Now this is very simple. Okay, it is very simple. So it's exactly what we got here. This is the same thing. Okay, so this is very simple. Now to determine prime factor of a number, all you need to do is and use any method that is comfortable for you, that is convenient for you. You can use the prime factorization method by using prime factors only to divide the number, or use a factor tree by using any two numbers, any two factors of that number. It could be a prime number, it could be a prime number. All you need to do is make sure you generate prime factors from those numbers. Voila, it is very simple.
Highest common factor. The highest common factors of two or more numbers is the greatest or highest number, which is a factor of each of them. To find the HCF of a set of numbers, there are basically three things you need to do. Okay, now number one, you need to express the numbers as a product of prime factors. You would also find the common prime factors and then multiply the common prime factors together to give the HCF. Now, the HCF is the simple acronym of the highest common factors. Now, let's get to business. Now, if, for example, you're asked to find the factors of, let's say you have something like it says, find the factors of 216, 216, 288, and 360, for example. Now, it is very simple. Okay, it is very simple. So now, one thing we need to do is we are going to find the prime factors of this, the prime factor of this, and then the prime factor of this one also too. Okay, now this is what we're going to do. We're going to do it somewhere around here. Okay, now let's just draw a line, and then we have another line this way, and then we're simply going to write the number 216. Okay, so I'm going to do another one here. I'm going to do another one here. Okay, I'm going to do another one here. I'm going to write 288. I'm also going to do another one here. Now, please just watch what I am doing. Watch carefully so you can learn how to do it. It's very simple. Now, I'm going to look for the prime factors of this number by dividing it using a prime number. So I'm going to start with 2 in 216. That's going to give me 108. Okay, so I also use 2 to divide it because I'm sure it will divide it 54. So I'll use 2 to divide 54, and I'm going to have 27. 2 can no longer divide it, so I'm going to use 3. 3 in 27, that's 9. 3 in 9, that's 3. And 3 in 3, that's 1. So I have the factors written there, so I'm going to leave it there. Now I'm coming. 2 in 88, that's going to give me 144. 2 in 144, I'm going to have 72. No, I got my 2 properly. So 2 here would give me 36. 2 in 36 will give me 18. 2 in 18 is going to give me 9. Then I have 3 in 9, I have 3. And 3, I have 1. I'm going to start with this one again. I'll start by 2, and that's going to give me 180. 2 in 180, that's going to give us 90. 2 in 90, I'm going to have 45. So I'll use 3, that's 15. I'll use 3 again, and I have 5. I'm going to use 5, and I'm going to have 1. Okay, now I'm done determining the prime factors of these 3 digits. So I'm just going to do something here now. I'm going to write them out. So I have 216. I'll have it this way. I have 288. I have it that way too. And I have 360. I have it this way too. Now I'm going to write out the prime factors here. So I'll write it out. So I have here I have 2 times 2
times 2 times 3 times 3 times 3. Okay, so I'll go to the other one. I have 2 times 2 times 2. There are 4 2's there. So I have 1, 2, 3, 4, 5. Okay, there are 5 2's times 2 times 3 times 3. Go to the third one. 2 times 2 times 2 times 3 times 3 times 5. Now be very careful. You need to count these things. Again, you need to double check. So you have 1, 2, 3, 4, 5, 6, 7. Yeah, 1, 2, 3, 4, 5, 6, 7. And then you have 6 here. 1, 2, 3, 4, 5, 6. 6 there. 1, 2, 3, 4, 5, and 6. Now, don't forget, I said, now what we have done here is we have been able to express the number as a product of prime factors. So we'll find the prime factors of each of these numbers. Now the next thing says we should find the common prime factors. So we're going to find the common prime factors. Now, how do you find the common prime factors? You need to look at the numbers that is here and on this side and on this side too. So those are common factors. So we're going to circle this one this way. So we have this is common. Okay, this is also common. This is also common. Carefully, you do it that way. Carefully look at it. Okay, 3 is common. I'm going to have it this way. And see carefully. You have to draw it carefully. 3 is also common. You have to draw it carefully. Okay, and then you look at it properly. Okay, okay, we have just 3 on this side and 3 on this side, and there's no 3 on this side. So now these are the common factors. So you're going to write them. Common factors. Common factors are what are the common factors? Common factors are 2 times 2 multiplied by 2 times 3 times 3. Okay, do you see it? Okay, now, and we are going to have our highest common factor to be. Now, how do you generate the highest common factor? Now, the first thing we need to do is we're going to multiply these numbers out. Now look at it. 2 times 2 times 2. This is going to give me that is 2 times 2, 4 times 2, that's 8. And then I'm going to have 3 times 3 is what? And that's 9. And I'm going to multiply it together. So 8 times 9 gives me 72. So therefore 72 is the highest common factor. Now, so 72 actually means, in a common sense, it means that 72 will divide 216 equally without a remainder, and will also divide 288 without a remainder, and at the same time divide 360 without a remainder. So 72 remains the highest factor of these three numbers. It is very simple. Okay, now so this is what you're going to do. Remember, you're going to express the numbers as product of their prime factors. Then you're going to find the common prime factors, and you're also going to multiply the common prime factors together, and that will give you the highest common factor. So it is going to be, in fact, it is exactly like this. Okay, now what if you are given something like this?
Now, what if you're given something like this? Now, if you have something like this one that says find, it says we should find the HCF, that's the highest common factor of the below. Okay, if you have something like this, find the HCF of the below, and it says we should leave our answers. As prime factor. Okay, since we leave our answer as prime factors, and it also say we should use index notation. I mentioned it earlier, index notation. Now we're going to leave our answer as index notation. Now let's look at it. Example one. For example, now when you have something like this, says if you find something like this, when you have 2 times 3 times 7, and we have something like this, and then you have 2 times 3 times times 3 times 5 times 5. We have is it a semicolon? I'm not sure what it's called, but that is used to separate those numbers. So you have 2 times 3 times 5. Now, I think there are powers on them. So you have here, it says 2 raised to power 3, and there you have 3 raised to power 2, and then you don't have anything there. So you have here 2 raised to power 2, and then you have 5 raised to power 2. On this side, you have 2 raised to power 2. You have 3 raised to the power of 3, and nothing is on 5. Now, these are 3 different numbers. So you have M1, you have the second one, and you have the third one. Okay, now the first thing we're going to do is we are going to express them. Now, let me do this one. Now, this one becomes it says 2. I'm going to express them. I'm going to expand them. Raised to power 3. Sorry, 2 times 3 times 3 times 7. Okay, so that's what that one says. The third one now says this one says 2 raised to power 2, 2 times 2 times 3 times 5 times 5. Okay, so it says 5 raised to power 2, and that is it. And the third one, I'm going to put it this way, and I'm going to put this way. Let me put the arrow properly, and that one goes this way. It says 2 power 2 times 3 times 3 times 3. That's 3 3s, and times 5. Beautiful. Now, as you can see what I'm doing, okay, the question is written in index notation, index form. What I've just done is I've been able to expand them properly. Okay, and the next thing I'm going to do is I'm going to look for the common factors. We look for their common factors, and I'm just going to look for their common factors. I'm going to change my now. This is 1, as you can see. It's common. This is also common. 3 is common, as you can see. It's common. Each one is common. So I have 2 here. I do not have any 2 here. I have 3. I do not have any 3. I have 7. I do not have any 7. So I have just 3 numbers that are common. So I'm just basically going to write it 2 times 2 times 3. Okay, now, and I'm going to say I have the HCF. The HCF, remember the question says we should leave our answer as prime factors, and then we should use our index form. So what are we going to do? I'm just basically going to write the answer exactly the way it is. Sorry, I'm going to write. Okay, now I have just 2, so I'm going to write it this way. As you can see, I'm going to use look at it. Boom, bullseye. So this is the answer. That is the HCF. Now, if the question wasn't, if the question didn't require us to put it in index form, I'm sure the answer would just basically be that's 2 times 2. That's 2 is power 2 gives 4. 4 times 3. That's 12. Boom. Okay, that's basically going to be our answer. That's basically going to be our answer. But we're asked to leave our answer in index notation. So this is very simple. This is how to determine the highest common factor. The highest common factor. Now, you can practice the highest common factor by doing this. The lowest common multiple. Now, the lowest common multiple of 2 or more numbers is the least or lowest, which is a multiple of each of them. Now, the simple method of finding the LCM of numbers is the prime factorization method. Now, how do you go about that? Now, first draw some vertical lines to make columns. Now, are you listening? Draw some vertical lines to make columns. Put each number in a column and begin to divide them with the lowest prime number possible. Now, it is possible that one prime number cannot divide into a number exactly. Now, do not worry about that. Now, just simply bring such number down under itself and continue to divide the rest numbers until it remains 1 in each column. Now, the LCM of all the numbers is the product of the prime factors. What if you're asked to find prime factor of this number? For example, you're asked to find prime factor of, now it says find the prime, it says find the LCM of 20, 25, and 30. Okay, so we are basically going to find the LCM of 20, 25, and 30. Now, this would explain all what we have just said earlier. Now, don't forget, it says draw some vertical lines to make column. Now, so I'm going to draw vertical lines just like it is said. So I have vertical lines this way. It's very simple. Now, so we're going to put each numbers on the column, and then we'll begin to divide them. So then put each numbers in the column. So I have 20 here. Okay, I have 25 there.
and then I have 30 there. Okay, now I'm going to divide these numbers using a prime number. So I'm going to use the lowest prime number first. Now, boom, so I have 2. So 2 in 20 gives me 10. Now 2 in 25. 2 cannot divide 25 except you have a remainder. So what do? We put the number down itself. Now this means it cannot divide it except with the remainder. So 2 in 30 gives 15. Okay, do you see it? It's very simple. Now the next thing is you're going to draw your line this way. Just keep drawing the line to separate one point from another. So we're still going to use 2 because we have numbers that can still be divided by 2. So here I have 5. 2 can still divide 25, so I'm going to put it down. Don't forget, always keep putting it down. And then 2 can divide 15, so I'm going to put it down this way. Okay, now, boom, this is it. Draw your line. Here, I'm going to, 2 can't divide any of the numbers, so I'm going to go to the next number, which is 3. Okay, I'll try 3. 3 can't divide 5 except with the remainder, so I'll basically have a 5. I'll have my 25. And 3 can divide 15, that will give us 5. Now, the next thing I'm going to do is I'm going to draw my line. And then I'm going to use 5 here now. So 5 in 5 will divide 1. 5 in 25 give me 5. And 5 in 5, 1. I'm going to draw my line still. And I'm going to use 5. Don't forget, my objective is to turn these numbers to 1. So 5 in 1 is 1, 5 in 5 is 1, and 5 in 1 is what? 1. So this is very simple. Now, as you can see, I have the prime factors here. Prime factors here as prime factors are what's 2 times 2 times 3 times 5 times 5. Okay, so as you can see it, now I'm going to look for my LCM. So I'm going to multiply these numbers together, but I can do it in stack. Don't forget, it's better you do it in stack so you don't make mistakes. So this is 25. Now see the way I'm doing it. And then I have 3 here. So I'm going to put my multiplication sign. So here I have 4 times 75. So that is going to be very easy for me. Okay, 4 times 75 is 4 times 75 is 300. 300. Boom. 300. So 300 now becomes the LCM. As you can see, 300 becomes the LCM. Okay, so this is very simple. You can see it's very simple. So it means that these numbers will divide 300 without remainder. So 300 is the multiple of 20, 25, and 30. That is the lowest common multiple of 20, 25, and 30. It is very simple. So, and this is the best method for it. This is the best method for it. Okay. Now, sometimes you may be asked to find something like this, like what we had before. Like when you have something like this, you can be asked to find something like this. Now, supposing you have a question like this, question number 2. Now, and then you have, it says find the LCM. Find the LCM of 3 times 5, 3 times 5, and then I have a semicolon. No, not semicolon, maybe something, I'm not sure what it is. Okay, you have this one to separate these numbers together. 2 times 3 times 3. Then you have this one. Then you have 2 times 2. Sorry, 2 times 2 times 3. Now, what if you have numbers like this, and then it says that we should leave our answer in prime factors? It says we should leave our answers in prime factors. So I'm basically going to do the two. So I'll leave my answer in prime factors. I'll also leave it as a normal number. Okay. Now, what am I going to do first? I'm going to, so you have one this way, you have another one this way, and then you have another one this way. Okay, so these are basically three numbers. So three, I'm going to write it out. So I have 3 times 5. Sorry, 3 times 5. And then I have 2 times 3 times 3. And then I have 2 times 2 times 2 times 3. Okay, so we have something like this one now. Now, so what am I going to do? When you're looking for the LCM of this number. Now, the first thing you should do is we are going to write down the possible numbers that we see here. First and foremost, we are going to look for the common numbers first. We're going to look for common numbers first. Now, see, this number is common. 2 is common here. Okay, 2 is common here. So I have 2 here. So I'm going to write my 2. So 2 multiplied by okay, so I have my 2 here. 2 multiplied by this. I'm going to look for another common one. 2 is common, so I have 2 here. I have these 2, and then I have these 2. So I'm just going to put them down exactly. I'm going to put them down exactly. So I have 2 times 2. Okay, so I have 1. I have this one. These ones are common, so I put one of them, 2, and I have these 2 here, so I'm putting them down like that. So I'm going to go and look for another common number. So I have 3 is common. Now watch it. 3 is common. Okay, so I'm going to put it down. So 3 is common times 3, and then I have one other common 3 here, so I'm going to put it down times 3. Okay, don't forget this one. I actually refer to this one. Okay, that's what I have here. Okay, you can see that's what I have here. And then I have 5. Okay, you can see 5. So I'm just going to put the 5 down here. You can see it's kind of very different from the HCF. Okay, now I have the common factors here. I have the common factors, or will I say the factors here. Now I'm now going to look for my LCM. Okay, now the question says that we should leave our answer in what? Leave your answer in prime factors. Now, so this is the answer. If we leave our answer in prime factors, now we can also leave our answers in index form by doing something like this one. I've said it earlier. So you have 2 raised power 3, then times 3 raised power 2, then times 5. Okay, I've not written my raised power. So I have 2 raised power 3, then 3 raised power 2. Okay, so this is the answer if we go by the instruction. So you can either take this or put our answer in index form. So how do we put our answers in index form? Sorry, put the answer in normal form. Now, if you look at it, 2 raised to the power of 3, that is 8, times 3 raised to the power of 2, that's 9, and then times 5. Okay, so we can now say 8 times 9, that's 72, multiplied by 5, and our answer, which is going to be the LCM, will now be, this is our calculator here. We may not necessarily need our calculator, so we may just say 5 times 2, that's 10, and we're going to carry 1. 5 times 7, that's 35, that's 360. 360. Bullseye. So that is very simple. It's basically very simple. So I want you to take note of what you have learned here in this lesson. Practice these things very well so it becomes you, and then you can solve any question relating to prime numbers, prime factors, HCF, LCM, and name it. Okay, so I want you to take these questions and practice with it so that you can get better. See, to become a mathematician, you need to keep practicing. You need to keep practicing, and then when you practice with questions, you get better in mathematics, and then you become a mathematics guru. So thank you so much for your time. I'm sure I've been able to make you understand how to solve new things today. Now, do not forget to subscribe to this channel, turn on the notification bell so that YouTube can show this video to other learners. And I'm going to see you in my next video. Bye-bye.
Oh.